Hi, yes, I'm Moritz, and I'll talk about like the open source project that I've talked about in the worked on in the last 6 months or so. Um, Apologies about the slides. I got finished at roughly 5 a.m. today, so it is 10 a.m. Yeah. So basically, what is the problem that we're trying to solve? We have a UI, right? Like I'm just taking Codeberg here as an example. And I have selected one issue here that I've opened, and I'm going to press the close button. And now a bunch of things in the UI should update optimally, right? So first of all, the checkboxes should change, right? Like I've closed the issue is probably not there anymore. So like these checkboxes need to change. This issue needs to be removed if I'm in the like open view here. But like if I'm in the all view here, only this state should have to change. The number of open and closed issues should change. The number of issues up here, which is the number of open issues, should change. And if you look at it, like even a simple button press, right, like has a lot of implications on the UI. And that is difficult. But what's even more difficult is for somebody else, there should be like a red dot in the top right. So somebody else, if I press the close button optimally, this demo issue vanishes for them, even if they're on a different tab, because everyone should see the same state of your application. That's the fundamental issue that we're trying to solve. That like all of these things should update not only for yourself, but for everyone else that also uses the application. And UI, I don't know why you use the word animations. UIs are highly reactive in 2026, right? I'm Moritz. I've been writing software for almost 20 years now, almost always involving the web in some way. These are my own views. I do not represent anyone else. So like this is just mine views. And what I'm talking about today is the problem that we're trying to solve, how it's been solved in the front end, and what's missing to move it to the server as well. The inspiration of Convex, which is the idea behind PG Reflex, what I like it, but also what issues there are. And about PG Reflex, how it works, the stack, developer experience, demo, and future of the project, and then like a bit about community stuff, like other projects, maybe about how can I use this, contributing what's needed for a 1.0 release. And yeah, there is a demo. Unfortunately, it's not mobile ready, and I don't think I see any laptops in the audience, so I'm just gonna show it off on desktop. But like while we're here, I'm gonna ask who here knows TRPC, Convex, or programming. Hands up. Anyone knows any three of these things? Okay. Then I'll try to keep the talk a bit low, but like as a note, we're talking about a programming framework, so I'll have to show some code, sorry. Cool. So basically, this is the idea is a website driven by PG Reflex, and I'm gonna open up the same website in an incognito tab, right? Like this is just an incognito window, meaning there's no data shared between like this half of my screen and the other half of my screen. And I'm gonna create a new account here, stage, and I'm gonna make myself green. And the cool thing is now, with a framework like PG Reflex or Convex, I can press on a thing and like it updates automatically in the other tab. And that works in both tabs. And I can do things like this. I can create a new poll, and like it appears for everyone. That is the cool idea behind something like PG Reflex. I have also like built a small chat application. You can all check this out as well, like chat.rk.eu/ yeah. And then I can send a message, hi, and it appears everywhere. And the cool thing about a reactive framework is that if I name myself to a stage demo up, then like this also is updated everywhere. And again, this works over the internet, hopefully with low latency. And the cool thing about this is that it works just as well no matter how I update the values in the database. So as soon as I change the name of the users in the users table in the database, everything updates. Cool. That is what we're trying to make, or like what I've built. And now we're talking about like why this is and how this is. we're talking about like UI rendering a bit more, like what has been done in the front end so far, and like what are the solutions. We have the default in UI frameworks, which is still used widely, which is often called imperative rendering. It's used by frameworks like Windows Forms, right? And even I would classify normal JavaScript as it. So how does it work? Well, you declare your UI, or you like add stuff to your UI, and then if you want to change something with it, you write code that does it. So here I have an input, text input, and I check if the first character is A4. I'm gonna take the pay button that I have done here, and I'm gonna set it to pay Visa, because Visa credit card numbers always start with a 4, and otherwise I'm gonna set it to pay something else. And here's like a live demo, because we can do this. I can, if I type ASD, it's pay something else, and if I start with a 4, right, like it says pay Visa. That's cool, but like if we notice that if I refresh this page, it only said pay. So if I press a 4 and then I go back, it says pay something else. And that is kind of the big issue with this imperative rendering approach, that we can very easily add inconsistencies to our UI. It's very complicated. And Facebook, a company with a lot of money and probably not a lot of morals, noticed this issue as well. This is one of the reasons they made React. And the issue is that like if you have the chat and one chat message comes in, the amount of things that need to be updated is immense, right? Like if a member joins, this text needs to be updated. If the user isn't on a chat message and they're on a chat page and there's like a new thing, should add a number notification here. Inbox 1 should change. If there's a new chat message, this needs to update. The message needs to be appended itself. And there's also like chats in the bottom right. Like so many places on the page need to update, and that's the idea of React. What do? Well, we store the state in one place, and then we just basically say what should it look like based on the state. So instead of saying, hey, I want an input and like I'm going to change the text, blah, 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 or the button, I'm going to change the text, I'm just going to say the text of the button is pay, and if it starts with a 0, I'm going to say Visa and otherwise something else. So I'm just going to say this is what it should look like. I don't care how I get to the state. I'm just going to say the UI should now look like this. And that's the basic idea, and like that's the basic issue that like programming has been solving for, I don't know, 20 years almost. We have trying to do these things. That is a very natural approach, right? We just like have a function where we take the state and map it onto a UI, like for the mathematicians in the crowd. This is kind of like functional programming for UIs, and that is a lot of the things what React is, what all of these front-end tools are about. And this has been the default since forever. I don't know if anyone here remembers PHP, but PHP is kind of that where you declare what the HTML in the end should look like, and the user makes a new request and loads the page anew, right? Like if you look at an old forum, if you entered your post in a like PHP VB forum, I don't know if anyone here is old enough to do that, and you press send, right? The page reloads, but it is in the end that declarative UI where like the programmer only needs to say what it should look like and not like what should change. And that's a very powerful paradigm. But again, we're still talking about the issue. This only works inside a front end, and there's nothing that's like if something on the server changes or if something on the database changes. That still requires a lot of engineering effort. And back to the problem, right? If Bob closes a PR, how does Alice know without reloading her page? And this is where Convex come in. Convex is the aforementioned closed source solution, well, open source solution to the problem that is, however, made by a VC-backed company. And it is a really cool solution. And from a technology perspective, I like a lot of the things they've done. I have some small issues with it that I'll go into. But like, what is Convex? Convex is a framework, a library that is going to be the backend for your TypeScript app. Basically, it's the entire backend framework similar to Next.js, or like similar to, I guess, like MVC, ASP.NET in C# land. And the cool thing about Convex is, what they say about themselves is, we're always in sync. Convex libraries guarantee that your app always reflects changes to your front-end code, back-end code, and database state in real time. No need for state managers, cache invalidation policies, or WebSockets. So they claim they have solved the issue, and like they have. How does that work? Does it work if I do this? Yes, okay. They have 3 big parts, right? Like they have their own database engine, their own backend server / code runner that runs your code, and then they have the front-end framework. And they manage basically the interconnection between all of these parts so that you don't have to worry about it. What can it do? And like this is a video that like I came across that was the reason why I started writing, why I started being interested in Convex in the first place. This is by Theo Brown, who is an startup guy.
Here is the app that it created for us. I'll make another channel quick. Hop in here. Sup, nerds. I'll add another preview. I'll send another message. I'll send that in this one. You'll see it automatically appears in the other chats. Cool, awesome. But they added something I hadn't even thought of. And this was the like, holy shit, this is the future moment for me. I'm going to go to the database tab. This is an embedded version of their dashboard. And by embedded, I mean it's literally just their dashboard. Here's our data. Let's hop into messages. The message we just sent here is another message. I'm going to change this to please don't forget to subscribe. Now I'm going back to the preview. And it already changed. There is no desync. The amount of problems that go away, the amount of mental overhead that I didn't realize I was putting in to make sure everything would be synced enough to be a good experience for my users, that vanished the moment I tried that. And the hardest part is like, for us as devs, this is crazy. But to a normal person, this is just how you would expect it to work.
And while I often disagree with you, in this case, I agree with him a lot. And this is how things should work, right? And this is the entire idea behind something like PG Reflex. And the cool part is that we can replicate this demo. And I can just, like update my database. In this case, we're going to do it via the command line because we're cool and hackers. And then I'm going to say update messages, set content equals AAA, and I'm going to just like set all the messages to have the text AAAA. And this is a destructive command, but I am willing to run it. And you can see like just by running a normal standard database upgrade, the front end immediately updated at the same time. And that is truly powerful because it solves so many issues in practice when you're trying to develop a bigger web application. Convex is pretty cool. Like, I genuinely like it. It is open source, so like I'll have some asterisk for this later. And it has genuinely a very good developer experience. The dashboard is really nice. You have seen it in the video, right? Like, it's a nice view where you can see all the data edited live and have things. But like the thing that I really like is their code, which is, in my opinion, really straightforward. To make something work live, all you need to do is declare, hey, I have a query that I would like to be available in the front end. And if the query is run, I want to go to the database. I'm going to query the tasks where completed is false. So like all tasks in my to-do list app that aren't completed yet, and I want to give them to the front end. And by doing this, I'm making a live query automatically. That's really powerful. And then all I have to do in the front end, again, is declare like, hey, I want to use this query. I want to use the get all open tasks query that like I have not, like this is called list, but like it should be get all open tasks. And And this automatically updates if the database changes. And that's like truly powerful because I don't have to worry about like anything being out of date. I just say like, I want all open tasks in the front end, and it happens automatically. And that is really a paradigm that like I wish was as easy. And like that's why I built PG Reflex. And at first, it certainly felt like magic. I didn't even know how it was done, right? Like, how does the frontend know which data update in the database? Did it do something like symbolic execution of the TypeScript and then like run stuff in the database? Like, I had a lot of theories that like were extremely one. In the end, how this works is quite simple. In the front end, we have this like use query thing, right? And that subscribes to the server function via WebSockets by simply sending a message. Basically, it just sends a message to the server like, hey, I want to subscribe to this. And then we have this getOpenTasks function, right? And Convex runs this code once. And yeah, whenever the return value of handler would change, we rerun this code. And now we just need to know when would the return value of handler change. And that's the difficult part. But I'm going to leave the code up here, right? We have the database. We're going to query the tasks table, and we're going to check if completed is if false. And only then we return the value. And so we can do a bit of a, thinking about it. If we look at what a database can do, you can do basically three-way operations. You can insert new rows into a database. You can update existing rows. And you can delete rows. And so if we think about this, I am going to insert a to-do list task with the title hello, the current app now, and I'm going to set completed to true. This thing, if you think about it, would this affect the return value of this query? No, because completed is, we need to check if completed is false, so like this wouldn't affect it. Here, we have the tasks table, and we're going to insert completed as false. So this one would change the issue. And so like we can already see for these two first updates, it was very easy to determine if they would have changed the return value of the query. Then we have, we're going to set completed to false, where the title is hello. So now this would again change the return value of the function, because completed used to be true, but like now it's false, which means this is now part of the result set when it wasn't before. And then we're gonna complete this incompleted one, right? And that would, again, would update the result set. So it's actually quite easy to tell. The rule of thumb is if a document, or like if a row matches before or after the update, if it matches the conditions of the query, then it would potentially affect the result set, and then we have to rerun it. And that's actually not that complicated, right? Basically, it is often super easy to tell whether a database operation would affect a specific subscription in the front end. That means we just need a piece of code that for every subscription keeps a list of conditions that would trigger an update, and then for every database change, we iterate over this list of conditions and rerun the function if necessary. And that's the entire magic with how you keep the front end in sync. And we then push the update to the client. That's it. And when I say it is often easy to tell whether a database operation would affect a specific subscription, Convex is engineered in a way that specifically only allows you to do things that it can keep track of in both directions. For example, this is why you cannot join from two different tables in Convex. I can go into why this isn't possible, but it isn't. This is why you cannot use. This is why you have to use a predefined index, because otherwise it's very difficult for Convex to keep track on what's happening. And this is why they don't allow like big updates, because that could be very expensive to check. But so like as a review, right? I have my web app. I'm going to make the initial query, get all open tasks. I have a mutation that then changes something in the DB. That updates the database. The database reruns the relevant subscribed query and sends a result to the front end. That is the entire magic of something like Convex. And if you notice, it loses a bit of the magic, and you get hubris and think, I can do this myself, which are famous last words from every programmer ever, including myself. And then you also get more annoyed at some gripes with Convex. Building a database is hard. I have the subtitle here, Ask Me How Now. I previously made a startup that built a database engine into their product, and it's just a lot of work. It's really hard, actually, and I don't envy them having to do that. And while they do use Postgres, MySQL, or SQLite under the hood, it's mostly as a key value store and based on the database contents. And the query engine is their own, which is fairly limiting in a lot of ways, right? You cannot aggregate at all with the query engine. They just don't support this. Queries that can't use a specific index aren't just slow. In Postgres, if you have a database with a table with 1,000 rows, 2,000 rows, and you can't use an index, it's still very fast. Postgres will fall back to what's called a table scan, where it reads the relevant parts of the table and still gives you results very quickly. But in Convex, this just isn't possible, because what Convex does is that it would send every document in that table to the app server, and the app server has to process all of the data, which can be very expensive. They don't allow you to aggregate counting things. So if you want to know how many tasks were created this week, the answer of Convex is what are you, a cop, use amplitude or something for tracking, or use a counters framework where you have to keep track of the counts from day one. So if you want to count something that you don't know you wanted to count, Convex doesn't allow you to do that. There are good reasons for this. They talk about them at length. I still disagree with them because normal database can do these things and still be plenty fast. There's also extremely strong vendor lock-in. Convex owns your data. They run the database engine. They run the sync layer that you're using. They run the front-end data management. Instead of, for example, something like React Query, they own your database query engine, and you run your backend app server code with them. So if you switch to Convex and then decide 6 months later, I don't like them, or they make the prices more expensive, then it is a big issue to move away from them. I'm not a person that is write code so you can switch from Postgres to Oracle database if you need to. I think that is a stupid way to approach software. But if you are working with a VC-backed startup as one of your vendors, you must expect that they will shitify over time. That is just experience from a lot of startups. And so the switching costs for this are too high for me to use that. The switching cost, by the way, is good for them. They like these high switching costs. They like that your entire application is built around Convex, because that gives the nice thing that they want, which is annual recurring revenue. They love that. And yes, they will talk in public about oh, we will make it as easy as possible to switch away from it. But I can promise you that they like the fact that if you use Convex and you have invested a lot of work into your application that you've written with Convex, it's actually not easy to switch away from it. They don't hate that. And you could then say, oh, I can just host it myself. And this is where I come to my next point, where Convex is open source not. You can click on this link, right? And you will get most of the core code, right? Especially the crates here, right? You can see you have the Convex crate, which is, their engine, the actual database engine. You can get the database. You can get all of these things, and you can look at it. But it is not a full source. There's a lot of things in the Convex website, the Convex hosted version is what they call it, that you can do that isn't supported. For example, multi-instancing is not great. So by default, if you want a second database, you have to run a second Docker container, and technically on a different host, though you can get obviously around this if you are willing to proxy. There is no good role of permission management by default. Permissions in a database are important. So yeah. But the big one is, and this is the one that is very annoying to me, you cannot start multiple backend instances with the same data. So meaning your application server is limited to one physical machine. Yes, that machine can have 48 cores and be very powerful, But every single user that you serve needs to be served from the same physical machine. That is difficult. There is a planned fix for this that they've talked about for a while now. I have asked in the Discord last night, and I think it is not out yet. And regarding the first 2 points, there is a community project, Convex and Apps, that addresses some of these things. But yeah. Then licensing is always complicated, and I understand why they chose the license they chose. They chose the functional source license, version 1.1, which is basically you can use it for permitted purposes, and a permitted purpose is any purpose other than a competing use. So unless you're, for example, AWS, and you're say we host Convex for you as a thing, and you pay us for Convex, you can use it as open source. So the license is fairly permissive, and I also get why they limit that competing use thing, because AWS has destroyed project in this way. This license is written to address that. However, this is also in part why I don't know how Convex works in details. I have only looked at the source code of stuff briefly. None of the things that I looked at were relevant to PG Reflex, because that would have been using it for a competing purpose, and I don't do that. Cool. And then there's some things that are a bit unfortunate in my opinion, which is that if you want to join data, that's what I've talked about before, it's really annoying. So this is get task and offer. So you have a table where you have your tasks in there. Again, we're looking at a to-do list example. And then you have your users table where you have information about our users. And you want to know for a task which user has created that and want to show this alongside. And so I have to grab the task from the database, check if it's null. And if it's not null, I'm going to say, hey, I have this task. I want to get the username with this context. I'm going to check if the task and I'm going to pass the task.author ID if there is one, otherwise it's null. And then I'm going to get the username and blah, blah, blah. That is, in my opinion, a lot of code to replace this kind of join that I can do in SQL by default. That's just, in my opinion, a lot simpler. Also, PG Reflex has, in my opinion, a better API for that I can show off in a bit. And yeah, this is where we get to PG Reflex, because I can do better. Only I, and only maybe, because it's actually not super easy. My goals for PG Reflex were the following. I want this to be compatible with a standard popular web dev stack, and potentially even be transferable to other web dev stacks. I want the same powerful sync mechanics that Convex has. So I want this thing where hey, I update something in the database, right? And it updates in the front end. I want these sync mechanics. And I want this to be fully free and open source software. In this case, I've decided, to go by MIT license, which even if, it's loved by corporations, I think I want to do that. I want the same or better developer experience. I can talk about this a bit more towards the end. And I want also to have it with decent performance. So what did I do? I chose the stack that I use in my day-to-day job, which is TRPC, which is a framework for basically making a type-safe connection between your front end and back end if you both are TypeScript. And I'm going to use Drizzle as the SQL framework, which is a tiny ORM for TypeScript. And I'm going to use Postgres because Postgres is the best database. Fight me. And that is the stack. How does it work? We have three things that could be called server. Sorry. So we have the database, which is Postgres, the normal Postgres binary that you download from websites. Then we have PG Reflex, the PG Reflex server, which is internal in the code. Whenever you see server, it means the PG Reflex server. And then we have the app server, which internally I reference as client, because from my perspective, from the PG Reflex perspective, the app server is a client, because this connection here is all handled by TRPC. Cool. So what does, which slide number are we on? 45, and we are 42 minutes in. Perfect. Where I want to be. So what does this look like, right? In Postgres, in PG Reflex, I'm very similar to how Convex works. I also declare like, hey, I want to create an endpoint called me. I have to add it to a router technically. And then I want to have my procedure. That procedure defines if I want the user to be authenticated or not. There's like a bunch of internals about this. And then I can create a handler. And here I then say, hey, I want the secret of the logged in user. And I want to, from my database, select a single value that might be missing. So like select is I want to select something from my database. Single means I only want a single row. I know there's only a single row with that would fulfill the query. And optional means that like it might fail. So this is an extremely common operation. If you've ever worked on like a backend, this is extremely common. And then like I add in the where conditions in this like very nice syntax, which if we compare it to the syntax of Convex, right? It's context.db query tasks with index by completed q.eq completed false. I found this extremely verbose, which is why I went for this more simple API design where you just do these things. And here I want to brag a bit because that was actually a bit difficult. Yeah, this one is this. The cool thing is that like autocomplete entirely works. So like if I select the users table, right, we can look to where this is declared. We have an ID, a secret, a name, created at, and a color. And I'm going to remove the not null from the color. So like color might be now nullable. And so now I can want to say, I want to see where the name is hello, right? Like this gave me all users where the name is hello. But what I can't do is I can't ask for the name being null because the name cannot be null. The name cannot also be the number 1234, right? It could be the string 1234. And so only allowed values are basically allowed. And if I select the color, right, like I can check where the color is null, this is suddenly allowed. I've also decided that like I can handle is null. I don't have to do a special is null operator. So what I've tried to do is simplify this code and make it a bit more readable, especially if you have a free or for condition. You know, that this is a bit easier to digest. And I've tried to address the two things, right? Like one is select single, where you only have a single row, and then you have select single optional. These are super common use cases, so I've decided to simplify them a bit. And similar to Convex, we can then use those in the front end, right? Like it's just trpc.me. We can see I've exported me here. This is why this is me here. And say use subscription. And yeah, then I can just like, you know, display the name. And this is actual code, right? Like this works in the front end. And this is basically how the me endpoint looks, or what the me endpoint looks like. And yeah, how does this work though, right? And if you have been able to be following me earlier, then this should be easy. If not, then sorry, I don't have a better way to explain it. Again, we have like a list of conditions here, right? Secret equals secret. If and only if a row matches this condition in the users table, this would change the return value of this. So basically, if there was a change to the database and the row before after the operation had the conditions equals secret as true, then we need to rerun this query. And this is where the big, nice wall comes in. The WAL wall is the write-ahead log, which is something that I think every modern database has. Even SQLite has a write-ahead log. And basically, if you have a database, you want your database to be fast, as a rule of thumb. People don't necessarily love slow software. But if you have a database, it's also kind of rude to lose data. Like, you don't necessarily want to lose data either. So we need a way to be fast and not lose data. If I do an update or insert data into the database, I have to update the data on the disk and in memory. We can do this maybe fast. I need to update all indices, so like all the query, all the like basically automatically managed side tables that make queries to the database fast. I have to update them on the disk and in memory. And I need to ensure that there's no inconsistency if the database ever crashes, which basically means that like if I update a table, I should copy the old state of the table into a new file and then append, like my new change data and then update all the indices and then only then delete the old data when I'm certain. Only so I cannot guarantee that I'm not going to lose data. And if we think about it, that's very slow, right? Like I have to copy my entire data set basically, make sure that nothing is lost and that there's no inconsistency if the data ever crashes and do this for every single change. That's And so what if we just say, just update the stuff in the memory, which is extremely quick, right? Like we all know how easy it is to do a small mem copy. And then we just write until the database is bored and write the changes to disk at a certain point in time. We might still then lose some updates. And so what we just do is we have the write-ahead log, where we just keep a list of updates, inserts, and deletes to each table. And if we have that, we can guarantee perfect consistency suddenly, right? We just have the list of changes, and we keep this. And when we're bored, we update all the data structures and start with a new write-ahead log. And yeah, that's basically what I just said. From time to time when the database is bored, it can grab a state from memory, write this new state to the disk, and then start the write-ahead log from there. And if the database dies during an update, it just loads the last known good state. This is really cool, and this makes databases great. But how can we use this? Why is this useful for us? And well, if we think about it, we talked about hey, if we know insert, update, and delete statements, what data was changed, we can update the front end. Well, that's cool, right? So how can we use it? And this is where, in Postgres specifically, we have logical replication. This is from the Postgres documentation, right? Where your primary database writes to their write-ahead log. And then there is the write-ahead log streaming replication process that reads these changes. And as soon as there's a change, it can send this to a write-ahead log worker or a replication worker. And that worker then sends this data to a standby cluster. And this standby cluster gets all these changes live streamed to it. That is usually used because databases get lonely and they don't like to be lonely. And also they don't like it when one server dies and your application goes down. So you replicate it to a second server and then you can live see the data. But Postgres specifically supports to say hey, I'm not a second database, but still give me all the updates. And Postgres has multiple ways for this, and a lot of projects use this. And in practice, this is you set everything up and you get a list of update, insert, delete messages, and that's it. And this is exactly what we need to invalidate stuff. However, Postgres by default sends the smallest possible diff, right? The row with the ID 1234 was deleted. If we go back to our code here, right? If we say a user with the ID 1234 was deleted, this doesn't help us to check if that would have been affected by this secret check, right? So what we do need to do is we need to set the replica mode of the tables to full, which always sends the full table. That has a performance impact. Some database administrators may wince at that. In practice, when I measured it, even on busy applications, it's not that bad usually. It's slightly less performant, but like it's really not the end of the world. And if we put it together, right, I don't want to go too much into the thing, but like if you remember, we have had this, like nice reflex call here that like got stuff and like got a handler function. And we need to rerun this handler function, right? So all we do is we create a subscription group, we pass in a database function, which gives us a subscribe to method, and then we wait until the group is invalidated. And because we're in a while loop, we then just send out the data every single time. And like this yield is some TRPC mechanic. Well, that's basically an async iterator that like every single time we push something into the async iterator, it gets sent to the front end. And if we then look at, like, for example, the select single that we looked at, I'm just subscribing to the things with these conditions. I'm waiting till the subscription is finished, otherwise you get annoying race conditions that are uncool to deal with. And then I'm gonna, like send the conditions over to the server. And then, yeah, the server does the invalidation loop. If we look at PG Reflex, this would then be handled by this, like C# server. That C# server looks at all the subscriptions that you have and adds the conditions to a list. And for every change of the database, basically, we just iterate a list of conditions. And if something matches, we send the invalidation to the application server where you're running it. And that is the entirety of PG Reflex. And with this, you can do cool things like if I change my name to ASDF, it works. Yeah, we're going to get to the last part of this talk, which is what is the stuff that is left to do. Pagination, I want to write a helper for this because it's slightly complicated. There's still a couple of bugs left. I want to get ready for like a 1.0 release that is actually, like has some things that scale. Make hosting easier, write docs for it, make the server multi-threaded, make the server load balanced so like you can have multiple PG Reflex server instances running, make the architecture of the server slightly less insane, and potentially rewrite the server in Rust. If anyone is a Rust programmer and like wants to take this on, it's a great language for this kind of thing. I just don't like writing Rust, so I'm not going to do that. Are we production ready? Probably not, but like you're welcome to try. I have been using it, and I will use it more. But like, yeah. For the community, I'm at the event. I promise I'll keep working on this, and feel free to help, especially with the docs and server stuff. And then last slide, actually, notable other projects is PG Lite. This is basically run Postgres inside your node process or like your browser, similar to SQLite, basically SQLite for JavaScript. And they have a cool feature which is live queries, where they do basically the same thing, as far as I can tell, where basically you have your query. If the results of this would change, you get a callback, which you can use. And if I'd known about this, by the way, I might have used PG Lite. It's a really cool thing, but like there are some drawbacks, so I'm not entirely sure if I would have used it. Anyway, thank you to the audience for listening, to the Convex team for Convex, because it's a genuinely cool project, and great that you've pulled it off. Noah for teaching me that, as the saying goes, everyone just cooks with water, right? Like Convex doesn't have any magic that I don't have, and many others of my friends. And yeah, apologies for finishing the slides at 5:16 a.m. Procrastination is very fun. Thank you.
Thank you for this amazing talk. We've still got quite some time for questions. So are there any questions? Okay. Where exactly can one find you here at the
event?
At the GPN, yeah.
I'll probably be around Hexa people or like just in the main area. Either wearing this or like the black, Nippers. Hoodie from one of the congresses.
Thank you.
Thank you.
Yeah, and otherwise, how difficult would that be to implement for any other database?
For other backends, then like if you're still with Postgres, like if you want to implement it, for example, with Go, that's actually not difficult. Like you just need to basically make a small wrapper around your ORM. If you want to switch to, for example, MySQL, it's probably possible. MySQL has also a replication. I just haven't looked into it yet. So it is possible to change this, and this is a powerful technique.
Okay, thank you. Any questions yet?
I can show off one thing at the very end, which is joins, which I made slightly difficult, so slightly more easy. I wanted to make it so you can, for example, have a list of pulls, and then like joins are always horrible in Convex, but like here you can give the result of this query and say I want to select something from the users table where, and then like created by. This comes from this pull list object is equal to the ID of the users table with the join key users. If Convex watches this and takes one thing away, please copy my API. I give this to you for free. This is so much nicer to annotate data. Thank you.
Would that allow multi-table joins? Is that correctly? Oh, nice. But actually, also was thinking about my work, and that could be useful there because we're joining quite a few tables.
Yeah, and the cool thing is that like you keep everything up to date. So and in sync and like in the front end, that is the nice thing. Like not worrying about like invalidations of queries and front ends and reloadings. Like that's all what we're trying to solve.
Very nice. Thank you. Any questions? Okay. Thank you. Thank you very much for Thank you very much for the talk, and a big applause, please.